Today's lesson, we're going to look at solving trig equations, and all this is one step further from what we did before. So what we're going to be doing is you're going to be getting an equation that you're going to try to simplify down to a simplified trig equation. So in this case, we get something like cos theta equals 1/2, or whatever the answer would be. And then from there, what we're going to do is use our cast rule and our unit circle to figure out what the angles would be. So in this case, we know that cos theta is 1/2 when we have a 60-degree angle. So in this case, we know it's 60 degrees, and we would use our cast rule to know that the other one would be at 300 degrees. And in this case, we want it to be in radians, because they're telling us that they want it from 0 to 2 pi. So we would just change those to radians, so pi by 3 and 5 pi by 3. If that was indeed the solution, I have no idea, but we're not going to solve this one. But the idea is we're going to take a trig equation, simplify it down to a simple trig ratio like we have here, and then we're going to solve it for the two possible angles. So a lot of this stuff will be the exact same as what we did before. The only real trick or the only thing that's new is to get it to a sine equation or a simple trig equation. So that's the first step. You want to make sure you rearrange the equation so that you get it down to just something simple. So here's a pretty easy example to start with. We have 2 sine theta equals 1. So our first step is get rid of that 2. So if we divide by 2 on both sides, we get sine theta equals 1/2. Once we have sine theta equals 1/2, we're good to go. So we know that for a 30-degree angle triangle, we know that the sine is 1/2 and the cosine is √3/2. So then we know our solution then has to be 30 degrees, and we can use our cast rule. So if we have 30 degrees in this quadrant, it's also positive for the sine in quadrant 2, which would be 150 degrees. And once again, we want it into radians, so we can convert the 30 and the 150 into radians to get pi by 6 and 5 pi by 6. So it's a pretty easy process. Usually the challenge is to get that simplified equation. So here's one a little bit more complicated. So we have 7 cos plus 5 equals 2 minus 3 cos. It doesn't matter if the angle's theta, a, phi, whatever. The symbol really makes no difference. We're looking for that angle solution. So this first one, what we'd want to do is let's bring the 3 over. So if we add 3 to both sides, that would give us 10 cos. And let's subtract the 5 on both sides. That would give us -3. So if we divide by 10, we get -3/10. This isn't one of our basic trig ratios. So what we're going to have to do is just go to our calculator. Let's make sure we're in degree mode, because we're just going to be solving these with degrees. So what we want to do is go second cos of -3/10, and that gives us an angle of 107.5 degrees if we round it up. Okay, so we've got one solution, so now all we got to do is figure out the other one. So we have 107, which would be something like that. And if we go 180 minus 107, that would give us a reference angle of 72.5 degrees. So now we know, so our one solution is 107. We also want to know where else is cos going to be negative. So this was a cos question, but we got -3/10. So it would be in that quadrant and in quadrant 3. So if we go 180 plus 72.5, that would give us an answer of 252.5 degrees. So that's our two solutions. We're done the question. So we just basically rearrange the equation, get it to be just regular sine, cos, tan, or whatever, equals a fraction, solve for it, and then find your corresponding angle that would also be correct. So the only other thing that's different now is we're going to look at writing these things in what we call the general solution. So general solution is when we're not given the angle is between 0 and 360, or in between 0 and 2 pi or something like that. Sometimes they won't give us a domain, they just say what are all the possible solutions. So it doesn't make sense for us to list out, if our answer was 45 degrees and 145 or something like that. We're not going to list out every possible angle to infinity. That doesn't make sense. So usually what we do is we just find our two solutions like we normally do from 0 to 360, and then we just write that as a general equation. So for example, if I said our solution was at 30 degrees, and that's our only solution we got, and we get that solution every time we go around the circle, every 360 degrees we go around and around, we keep getting that same solution. So we would write that as 30 degrees plus, oops, I messed this up, this should be 30 degrees plus 360 degrees in. So we're just adding 360 each time, which would be the same solution. Or if it was in radians, you could get something like pi by 4 plus pi, which would only be 180. So just depending on the scenario and the question, you're just going to be adding on these plus 360 or plus 2 pi's or whatever the case may be. So let's look at one of those. So here's another equation. So just like before, we want to simplify this first. So that'd be 3 cotan equals 29 over 29 minus 17, which would give us 29 minus 17 is 12. Then let's divide by 3. So 12 divided by 3 is 4. And cotan, remember, is the flip of tan, so that would be the same thing as tan of a quarter. So now we're good to go. So we can just on our calculator go second tan of a quarter, and that gives us an angle of 14 degrees. So now all we have to do is figure out what are our other possible angles. So we've got 14 degrees here, and that's when tangent was positive. The other tan coordinate is down here. So that would be 14 degrees there. So our other answer should be 194. Okay. So what we want to be careful of with these kind of questions is there any kind of pattern? So we'd have 14, we'd go to 194, then we would go back around, we'd add on 360, we would be back to 374. If we add 360 onto 194, we get 554, and we could keep on going by adding 360 each time. But sometimes you can see that there is going to be a pattern involved here. So if we actually go 14 plus 180, we get 94 degrees, 194. If we go 194 plus 180, that gives us 374. If we add 180 on again, we get 554. So this one's a rare case that our answers, because they're perfectly straight across from each other, we're actually only 180 apart. So the general form in this case, we would just say is 14 degrees is our one answer, and every answer after that is we're just adding 180 each time. So we can just write that as plus 180 n. And that's it. Where n is just any integer, so that just means we're going around multiples of 1, 2, 3, 4, or negative 1, 2, 3, 4. It doesn't matter. That'll just give us the exact same answer as our 114, 194, 374, and so on. Quite often when you do this, these two angles that you solve for won't be easy multiples like they were in this case. So what you might have to do in a case like this is write it as 14 degrees plus 360 n, and then you might have to have a second solution of 194 plus 360 n. So quite often you get two different general solutions, but because in this case they were straight across from each other, we can just simply add 180. We don't have to do the 360 for each. Okay, so a couple of key things to remember. So remember, with all of these questions, normally we get two angles per solution, right? Using our cast rule, we're always going to get two. So if I said we had an answer down here, we were going to get a second one possibly up here or whatever. So we'd have two different solutions, and generally then there's usually two general solutions, unless it was a question like we just did where they were 180 apart. And if our solution ends up being on one of our x or y axis, so either at 0 or 90 or 180 or so on, quite often we only get one solution, not two. So just be careful with those as you solve them. Let's do a few more examples. This one has a sine squared, but when you see it as 2 sine squared, remember that just means the same thing as sine theta squared. It's just a different way of writing it. So what we want to do, just like a normal question, is let's get it equal to just a regular sine by itself. So we'd have 2 sine squared equals 1. Divide by 2 would be our first step. And then we want to square root it. That would undo the squaring. So we get sine theta equals square root of 1 over 2. But let's break this apart. Square root of 1 is just 1. Square root of 2, we can write it as 1 over root 2. And now we can solve this. So we know from our special triangles that a 45-degree angle gives us a sine of 1 over root 2. So we have one of our angles is going to be 45. You could use your calculator. You could go second sine 1 over root 2. That would give you the 45 degree as well. And our other quadrant would be 45 in quadrant 2. So that would be 135 degrees. So there's our two solutions. we go back to the question, is it a general or is it a specific? This one's a specific, and we want it to be in radians. So let's just convert it back to radians. We'd have pi by 4 and 3 pi by 4. And we're done. If for whatever reason this didn't have the domain given to us and it was just in general form, then we would just do the same thing, or we'd have pi by 4, and that's our 45, and we'd go every 360. So we'd write it as 2 pi n, or 45 plus 360 if it was in degrees. And then we'd also write the second one, 3 pi over 4 plus 2 pi n, or 135 plus 360. So that would be our specific answer. We only look for the 2. If they want in general, we just basically add on that 2 pi idea in most cases. Okay, let's do one more. So here's another tan squared, but we have a problem. We got a tan squared and a tan. So what you got to do is we got to treat this question as if it was like a quadratic. So we'd have x squared minus 4x plus 3. You can see that's just a regular quadratic. So we would solve this by factoring. We'd go x minus 3 and x minus 1. And we'd say our solutions are x equals 3 and x equals 1, just like we would normally do. So what we want to do with these kind of questions is approach it the same way. So the only thing that's different is our x now is actually tan theta. So our factors should be tan theta minus 3 is one factor, and tan theta minus 1 is the other factor. Now we want both of these to be equal to 0, so that means we'd have tan theta equal to 3, just like we did over here. And then we're going to get a second equation of tan theta equal to 1. Because we're just basically making both these equal to 0, so we're just going to move the 3 to the other side and make it a positive 3, move the 1 to the other side, that makes it positive 1, and now we're done. So in this case, on your calculator, we want to go second tan of 3. Let's solve that one first. And that gives us 71.6 degrees if we round it off. And if we go second tan of 1, that should give us 45 degrees. We know that one is exact. Okay, so we got our two solutions, but remember for any of these, you're going to get 2 per answer. So our 71.6 degrees would be there, and using our cast rule, the other location that tan would be positive would down be in quadrant 3, so that would be 71.6 there as well. So our second degree should be 180 plus 71.6, so that would be 251.6 degrees. And then for our second answer, we had 45 degrees, and our other solution will be in the other quadrant as well, so we'd have 180 plus 45 to give us 225. So you can see in this case we actually have 4 different solutions instead of just the 2, because we had 2 factors, each one will give us 2, so we have 2 per equation. And this one we want it in general form. So, and let's do it in, we'll just leave it in degrees this time. So in degrees in general form, we would have 45 degrees plus 360, 225 plus 360, but once again, because it's a tangent, these lines end up being straight across, so we can actually simplify it down to just 1. So our first solution would be 71.6 degrees plus 180, because 180 plus 71 would give us the 251. Add another 180, that would give us the next one, and so on. So we just write it as plus 180n, and our second one would be 45 degrees plus 180n, and we're done. If we wanted to do it in radians, it'd be the same thing, but we just add on a pi instead. And that's all.